health study tracked a group of persons for 5 years. At the beginning of the study, 20% were classified as heavy smokers. So the probability of being a heavy smoker is equal to 0.20. 30% were light smokers, so the probability of being a light smoker is equal to 0.30. And 50% as non-smokers. So the probability of being a non-smoker is equal to 0.50. So they add up to 1, right? Results of the study show that light smokers were twice as likely as non-smokers to die. So the probability of dying given being a light smoker is equal to 2 times the probability of dying given non-smoker. Okay, but only half as likely as heavy smokers. Okay, so probability of dying given being a light smoker is equal to half the probability of dying given that they were heavy smokers. All right, so what I'm going to do here is I'm going to have it in terms of probability of D given N and probability of D given H. So I can divide both sides on here to get 1/2 probability of D given L is equal to the probability of D given N. And I'm going to have 2 times the probability of D given L is equal to the probability of D given H. And you'll see why I do that in a second. So, a randomly selected participant from the study died during the 5-year period. Calculate the probability that the participant was a heavy smoker. So they want the probability that he was a heavy, given that he died, he was a heavy smoker, right? So using Bayes' theorem, this is the probability that D given H times the probability of H over the probability of D given H, probability of H, plus the probability of D given L times the probability of L, plus the probability of D given N times the probability of N. So now this is going to come into play here, what I did up here. Okay, so this is equal to, so the probability of D given H is the same thing as 2 times the probability of D given L. And then, of course, the probability of H is 0.2 all over. So it's going to be the same thing, 2 times the probability of D given L times 0.2, 20, plus the probability of D given L times the probability of L is 0.30, plus, and then the probability of D given N is half, so half the probability of D given L, and then the probability of N is equal to 0.50. So as you can see, every single term in the numerator and the denominator has the probability of D given L. So I'm going to rewrite this where I'm going to factor out the probability of D given L on the bottom, right, in the denominator. So I can rewrite this as the probability of D given L times 2 times 0.2 is 0.40 all over. So I'm going to rewrite this as the probability of D given L, and I'm factoring out of each of these terms. So I'll have left 2 times 0.2 is 0.40 plus 0.30 plus, and then half of 0.50 is 0.25. And as you can see, I have a factor of the probability of D given L on the numerator and a factor of probability of D given L in the denominator. So that over that is just 1. So we're left with 0.40 over, so 0.40 plus 0.30 plus 0.25 is 0.95. And this turns to 0.421, which is answer D.